Okay, everybody, welcome back. We have just two more sections to cover to get you ready for your final. And so far, I had covered up through Unit 6. So I'm going to now cover Unit 7 and Unit 8. That'll give you two more worksheets to work on to review for your final. So let's everybody get your Schoology open and get into Unit 7. And that's going to look something like this. And I'm going to open up the not key and talk you through this one. Now this one has a whole bunch of stuff on it. Rational functions was pretty dense, so it might take me a minute or two to talk you through this. So let's look at this very first one. You remember one of my favorite sayings? If you can factor it, you should. So it's x over, x comes out, x plus 7. All right, so I'm going to rewrite that as a y equals here. And then something cancels. Cool. I hope you remember that that creates a hole there. And now this is a step that a ton of people skip, and it really hurts them. You need to write this function that results from this. Y equals 1 over x plus 7. Now that I've done that, it shouldn't be too hard to tell. Oh, this is one of those butterfly functions that's been moved 7 to the left. All right, but back to the hole thing. That caused a hole because there was one on top and one on the bottom. That means there's a hole at x equals 0. Now, a lot of people get stumped on, well, what if you have to give both parts of the hole? Well, 0 comma what? Well, all you have to do, if you know x is 0, is plug it into the resulting function, this function. See, if you never went and wrote that function, then it'd be hard to know what to put the 0 into. But now that I know that this is the resulting function, and I know x is 0, I just stick the 0 in there, and I get 1 over 7, which is 1/7. That's how I can tell where that hole is. All right, for horizontal and vertical asymptotes. Horizontal asymptotes are the horizontal asymptotes. You'll remember, I hope, that those are y equals things. And I want to run you through the different kinds of those real quick. For horizontal asymptotes, we had 3 ways they could come out. You remember these? Bigger on the top, bigger on the bottom, and say it if you know it. Same on both. Okay. So if this one were in question, it's a bigger on the bottom. How do I know? Because the degree on the bottom is degree 2 because it's got a square root in it. The degree on the top is only degree 1, so this is a bigger on the bottom. The rules go like this. If it's a bob, bigger on the bottom, then it's a y equals, and bob is an outsider. So it's whatever's outside the fraction. Do you see anything outside the fraction? No, so that's y equals 0. If it was a bigger on top, where the degree is bigger on the top, then there's no asymptote. So I like to say it's a no-bot. Just as a dumb way to try to remember, the answer is no. It's not y equals 0. It's y equals, there isn't any. There's no asymptotes if it's bigger on top. And for horizontal asymptotes, the last kind is same on both. And those will make you sob because they're much more difficult. It's not super hard. It's y equals a ratio of the lead coefficients. So if this had been a same on both, like for instance, this one is, see, that one's a same on both. Same degree, degree 2 on the top, degree 2 on the bottom, because if you multiplied it out, you'd have x squareds. If it's same on both, then it's a ratio of the lead coefficients. In this case, that'd be a 1 and a 1, and so therefore y equals 1 would be your asymptote. All right, so that's a reminder. You may want to, hopefully you're taking notes. That's what this is all about. The sub needs to pause it or something for you to take notes. That'd be great. And after I'm going to pause for just a second. You should take notes on this, and then I'll be back in just a second. Okay, I'm back from the little delay there, but so back to horizontal asymptotes. They come from bob, bot, and sob, and in this case, for this problem, this one is bigger on the bottom. You get how it's bigger on the bottom? If it's bigger on the bottom, which is because the degree is bigger on the bottom, then it's a bob and it's y equals 0. Cool. How about the verticals? The vertical asymptotes are totally different. You don't use bob, sob, and bot at all. Vertical asymptotes are just the things that crash the function down here at the beginning, those two things, which would be -7 and 0, and how -7 and 0 would make this bottom equal 0. Okay, if -7 and 0 are the two things that could crash this function, those things are either asymptotes or they're holes. When we canceled this one off, we knew that that one was a hole. Therefore, that's the only one left. That one must be the asymptote. X equals -7. Okay, and now how about the domain? The domain is all real numbers. You always start with that, except what are the things that would crash it? Again, they can be holes or asymptotes. X cannot be 0 because that made a hole, and X cannot be -7 because that would make this asymptote. What you're doing is you're finding a list of the things that would crash your function, and those things are either holes or asymptotes. All right, I'd like to skip down and have you guys try this next one. Pause for a second, I'll clean this up. Okay, so I'd like to have you try C in class right now, and then I'll show you in a moment what the answers for that would be. If you get done super quick, try D, because I'm going to assign that one too. But, all right, so try C and see if you can find the domain of it, the verticals, the horizontals, and any holes that it has. I'll pause while you give that a try. All right, so on part C, here's what you should have done. You should have said the domain was all reals except X cannot be -3 because C, it would crash it, and X cannot be -2 because C, it would crash it. Now the -2 one, that is from a hole. See, it's a hole at that spot because there's one on the top and one on the bottom that cancel each other. And so X equals -2 is part of the hole. Now if you're really smart, you're going to tell me what the rest of the hole is. -2 comma what? And you stick the -2 into the resulting function, which is y equals x minus 3 over x plus 3. Couldn't I cancel those? No, because they're not exactly the same. So if I'm going to find the rest of my hole here, it's because, or it's from putting -2 in here and here. -2, -2, and I get -2 minus 3, which is -5, over -2 plus 3, which is 1. -5 over 1, which is -5. All right, now the verticals. The vertical asymptotes, remember, the things here are either holes or asymptotes, and this one was a hole. Therefore, that one is the vertical asymptote, is at x equals -3. The horizontals, Bob tells us. But is this one actually a Bob? No. It's a, same on both. It's a sob. So it's a y equals a ratio of lead coefficients, which is y equals 1. So there we have it. Here's the hole. And here's the horizontal asymptote. Here's the vertical asymptote. These are the things that would crash my function. So it's all reals except x cannot be -3, x cannot be -2. All right, I think this is a good normal problem. I think it does factor on top and bottom. And of course, if you can factor it, you should. So do D as part of your homework. Hey, I said duty. Moving on. Pausing for a moment. Okay, here's some more where you have to graph them and they have holes and asymptotes and all that kind of stuff. And I know this can be tough for people, but your XY chart, I've told you, I've been singing the praises of the XY chart for so long. An XY chart can even, solve these for you. It'll work for anything. But you just have to be strategic about the numbers you pick. Because, for instance, if I pick like 6 in here, then I'm going to get 1 over 6 plus 4 is 1/10 plus 1. And that's like weird. It's 1.1. So I guess I could put in x equals 6 and y equals 1.1, but that's going to be difficult to graph. So choose numbers that are really easy to put in for x. So like if I was going to put in a number, my favorite option would be to put in, let me think, -3 would be really nice. See why? If I put in -3 plus 4, I get 1 on the bottom. So it's 1 over 1, which is 1. 1 plus 1, 2. So -3 comma 2. -3 comma 2 means that point has to be on my graph. All right, now that's kind of the slow way to do it. Here's another way to do it. Let's go and find its vertical asymptotes. This XY chart's pretty cool, but it's slow. Let's find its vertical asymptotes, its horizontal asymptotes, and that kind of stuff. All right? So what's its domain? All real numbers except x cannot be, look at the problem. What can x not be? -4 is correct. Okay, so then my next step is my the things that I listed there, which is only one thing, though that has to either be a vertical asymptote or a hole. And there's nothing canceling here, so it must be a vertical asymptote. So you're saying, Mr. Server, that there's a vertical asymptote at x equals -4. Yes. Here's -4. There's a vertical asymptote right there. How about horizontals? Who tells us the horizontals? Say it out loud if you know it. Bob. Bob is the one. I mean, is this actually a Bob? It is a Bob, and it's on the outside. Yep, Bob is outsider, so it's y equals 1. Y equals 1, because Bob is anything that's on the outside. Y equals 1. So look, here's the y equals 1 asymptote. You're starting to see that there's this 2 asymptote kind of theme. And do you remember that these problems were always like this? The 1 over things. So this is the basics of my graph of my rational function. Okay, now if I was going to look for one more perfect point, this point right here was perfect. And here's another point that would work out perfect with nice round integers. Okay, so there's my graph. Could you agree that that would have been like at the parent graph, except you shifted it to the left and then you shifted it up? Can you see that from those asymptotes that they went to the left and up? See, left 4, up 1. Now, was there any hole in this one? No. So I gotta be careful because I had circled some stuff like that just to like point it out, but that's not a hole in the graph. So, all right. So, the moral of the story: XY charts work, but you got to be really careful on this kind. And only a couple points on it would have worked. That point and that point would have come out real nice, but it's not the best way to do this kind. The best way to do this kind is get those asymptotes figured out and then graph it from there. I would like you to, at home, try number 3 and then go and check that. And let's see if I'd like to do more on this page. I think people had enough trouble on this that I think it'd be wise to just graph one more. I'd like you to try number 5 also. Again, you can make an XY chart for it, or if you can factor it, you should. And this one, I'll give you a hint. The 2 factors out, and you end up with a hole in the graph. So graph it carefully. And let's say that the graph looks kind of like this, and then there's a hole at x equals -4. Then you go to this spot in the graph right here, and you don't put a solid dot, you put an empty spot in, kind of like that. Now, I'm not saying that's what the graph looks like. I'm just kind of reminding you how a hole in the graph would look. All right, so try number 5 at home. All right, scrolling down, there's one more type of problem in here that we need to talk about, and that's where they give you the graph, and then you have to say what was the equation for it. I'm going to do number 8 with you. So take a look at number 8. Do you get this as a y equals 1 over x is the kind of the main theme going on here? It's the butterfly one. Okay? Except it's been moved. Which way has it been moved? To the right. And then also what? Up. All right. So right 2. So I go -2. That's to the right 2. And then up. I'm not sure. I can't tell from the numbering. My glasses aren't that great, but is that thing moved up? I hope that's up 1. That's what I'm going to go with. Up 1. Okay, because these dotted lines here, this is like the asymptote. It's been moved to the right 2, and I think it's been moved up 1. Okay, so there we go. There's my graph, right? No. What's one more little piece that's missing? So that guy. There's a hole at x equals, I think that's a 4. Man, I hope your resolution's better on your iPad than on my screen here. I think that's a 4. So therefore, it looks like there's a hole at x equals 4. So I got to go back into my graph and say, where would a hole have been? It would have been something on the top and something on the bottom. Put this in parentheses too. And the hole is at x equals 4. I hope you're thinking x minus 4 and x minus 4. Does that make sense? All right, good. Okay, so then last thought is I should give you one of those to do for yourself. sometimes people get really messed up on these, so I'd like you to try 2 of these. Do number 7. It's just a straight line. What? Well, I'll give you a hint. It has a y equals 1, 2, 3 vibe to it, but it's also a fraction function. I know because it's got holes in it here and here, and I'm going to have to put in a couple things to make holes in that graph. Then on number 9, I guess I'd try number 9 also if I were you. So I'm assigning also number 9 to do as part of your homework for tonight. All right, that one's got a fraction function, so I'd go y equals 1 over x as a starting place, and then say, where did I move it? Left, right, up, down, and it looks to me like it's moved to the left, and I don't want to do the whole thing for you, but also a hole in that one, so be careful. Got to include a hole. All right, that's all I have for this worksheet. I think these ones on the bottom are easy enough to write an equation for it. You just have to figure out, was it a bob or not? And these are all fraction function things, so you know you're writing an equation like this kind of thing. All right, but use the clues that they give you. Maybe I should do one of those just to be safe. Okay, number 10. Write an equation in factored form for a rational function. Right away, I know it's a fraction function, and it said factored form, so it's probably like this kind of thing. With a horizontal asymptote at y equals 0. When does y equals 0 come up? A lot of times if it's a bob, bigger on the bottom, then it's y equals the outside, and the outside is always 0, or almost always 0. So we could make this one a bob. So then I better make sure when I'm done, it's bigger on the bottom. Next, I need a vertical asymptote at x equals 4. All right, how would that happen? Well, the verticals are those things on the bottom, and if x equals 4 is important, then an x minus 4 would have done it. And a hole where x equals -1. So x plus 1 and x plus 1, do you get how that creates a hole at -1? Okay, good. Now, if I put something in here, it actually causes a problem because then it wouldn't be bigger on the bottom anymore. I really don't want anything else in here. I could put a number like a 1, or I could just leave it and have nothing there. Now it's a bigger on the bottom, so that's going to give me the y equals 0 thing. And it's got a vertical asymptote at x equals 4. That's because of this thing. And it's got the hole where x equals -1. That's that part. All right, so that's talking you through that one. Why don't you do number 11 also on this worksheet as a way to prove you know how to do that kind to yourself. Remember, you don't have to just do the ones I'm assigning. I'm kind of giving you the absolute minimums. And then from there, I'm hoping that you do more if you need more practice. All right, so that's the end of that one. Now we're going to go do the other type of problem here. And that is not rationals anymore, but factoring higher degree polynomials. All right, so factoring higher degree polynomials. Thankfully, we only have one worksheet in here, so we can finish this off with this one worksheet. Everybody open that one up. Higher degree factoring review C. Okay, these are the hardcore factoring problems. And these really are challenging questions. This first one's pretty easy, but this is our review sheet. Probably it's pretty fresh. I mean, we just did these the other day, right? So I'm not going to spend too much time on this part because we've just been doing the factoring and we just had the factoring test a few days ago. All right, so how would we start this? If you can factor it, you should. And you should have x and plus and plus. Nope, I'm wrong. Plus and minus. And how do I finish it? With a 9 and a -9. Okay, there we go. So that's factored form. Y equals all that. And then the solutions for that. Well, the only solutions I have are real ones because I don't need to do anything fancy with these. It's just x equals -9 and x equals 9. And the last thing is the imaginaries. There aren't any. How would I know if there were imaginaries? If you had something like this, for instance, that one would have been real, that one would have been imaginary. It's because if you were going to solve it on this kind, you'd have to have x squared plus 2 equal to 0, and that's one where you'd have a negative underneath the square root by the time you were done with it. And that's what forces you to have an imaginary answer, is when you do square roots of negatives. All right, so this kind would have had imaginaries. So for this, since there aren't any imaginaries, you shouldn't just leave it blank. You'd say none. All right. For number 2, it's a whole different kind of problem. I can't factor that as this is called a difference of squares. The next one is not a difference of squares. It's got 4 parts. And I'm going to give you a moment, and I'd like you to try by yourself to do that factor by grouping. Everybody try this factor by grouping. Factor the first part, factor the second part. I've called it divide and conquer before because you divide it up into 2 parts. You factor both parts. I'm going to pause for a second and give you a chance to try that one on your own. Okay, so you had some chance to try divide and conquer there. Here's how it should have gone. X squared comes out of both of those. And then you have x plus 2. On the right side, what comes out of both of them? I would take out negative 16. And then you'd have x plus 2. Why did I do it that way? So that that would match that. Now those can go to the front. And I'll put my final answer in green here. X plus 2 goes to the front. And then what's left after I factor out this and this is x squared minus 16. But if you left it that way, you should have factored it further. I bet a lot of you did. This one can factor into x plus 4 and x minus 4. So final answer, y equals x plus 2 and then x plus 4 and x minus 4. This one didn't even have any imaginaries. Remember, imaginaries would be if you had like x squared plus something. That would cause imaginaries if you had that as one of your factors. If it was x squared minus something, that would not cause imaginaries because that can be factored into real numbers, x minus 2, x plus 2, for example. So again, you're just looking for imaginaries. You're looking for things like that. That's the kind that give you imaginaries. And then you solve those. We'll factor one of those kind too. All right. So I'd like you to do number 5 at home. No, that's too easy. The ones I'm worried for you on, I don't want to waste your time here, are the big honking ones. So I think you should do number 7. Number 7 will be plenty of challenge. I'll just get you started on it. First thing I notice is there's something in everything. Do you see there's a number in everything and there's a variable in everything? So 4 comes out of everything and x comes out of everything. And what I'm left with is x to the 4th plus x squared minus 2. And how can I know I'm right? I can FOIL it out quick. That times that makes 4x to the 5th. Yay. That times that makes 4x to the 3rd. Yay. And that times that makes negative 8x. Yay. Okay. So I factored it so far, but I'm not done. You have to know how to factor this kind. Now, if you were on a calculator allowed part of the test, you'd be able to graph that thing and find out where its roots are. But in this case, I'm not positive, but I'm pretty sure they'd have been decimals. So it wouldn't have really helped you very much. So you've got to be able to factor this with plain old-fashioned FOIL kind of factoring. X squared and x squared. And then you think to yourself, what does that and that have to multiply by? Multiply to? They have to multiply to negative 2. And when I do the outside and the inside, they have to make positive 1. What multiplies to negative 2 and adds to positive 1? Positive 2 and negative 1. I'm going to double check that. Positive 2 and negative 1. Outside would be negative 1x. Inside would be positive 2x squared. And then you put them together and you get positive 1x squared. Yay, I win. But if I left it that way, I don't win. I have to factor it all the way. That one can still be factored with normal factoring. And this one, I've taught you how to factor with the intense kind of factoring. And some of you are really good at this, and it really helped you on that last test. So here's the final for this one. 4x comes right down from there. And then this part, and then the last part. This is the last part. The x squared minus 1 will be x plus 1, x minus 1. And the other part, I'm going to pause for a second and see if you can factor this into its 2 parts. Pausing. Okay, did you say that it was x and x to make the x squared, plus and minus because we need the middle term to cancel. And the last would be I and I because I have to have an I in here because this is the kind that gives me imaginaries. And the last thing is root 2 and root 2. It's always the root of whatever this number is. Okay, and then that gives me real solutions. Real ones don't have i's in them, right? So here's my reals, real, real, real. And that would be 0 and -1, x equals 0, x equals -1, and x equals 1. And the imaginaries are the ones that have i's in them. This would be -I root 2, and this would be +I root 2. And there we go. Okay, another one you should probably do just because it'd be good for you because it would have synthetic in it would be this one. So let's do number 10 together. Let me see how much time I've been going on in this video so far. Looks like 26 minutes. Oh yeah, we can handle a synthetic here. So how do I know what would work in my synthetic? I need to graph it and find out what's something that would work. So I'm going to graph it quick and find out what would work. Okay, I got to put it into my calculator here. X to the 5th minus 3x to the 4th, etc. And if I hit graph, it shows me the spots where it touches. It touches at -1, so that's a root. X equals +1. So x equals -1, x equals +1. And the last spot it touches is at 1, 2, 3. X equals 3. That is a gold mine for factoring. I know that those 3 things are in my answers, but I can only do them one at a time. So I pick one. Doesn't matter which one. So may as well pick the 3. So I'm going to put 3 into it with synthetic, and I'd like you all to try setting this up and solving this with synthetic. I'm going to encourage the sub to pause at this point, and I'll let you give that one a try. Okay, so hopefully you had 1, -3, 5, -15, -6, and 18. And drop it like it's hot. 1 times 3 is 3. Add them, 0. Multiply them, 0. Add them, 5. Multiply them, 15. Add them, 0. Multiply them, 0. Add them, -6, and multiply them, -18. And those cancel each other out. Makes a 0. It ended with a 0. Yay, I win. So this is x minus 3. And this part right here, this is important. That's how many x's. That's how many x squareds. That's how many x to the thirds. That's how many x to the fourths. So my equation is really x minus 3 and x to the 4th plus 5x squared, I skipped over the 0 there, minus 6. You can factor that next piece however you want, but I guarantee you that that and that are in it somehow. All right, so I'm going to factor it again. X minus 3, I'm going to this time use just plain old-fashioned FOIL kind of factoring. X to the 4th, x to the 2nd, x to the 2nd, and then what multiplies to -6 and adds to 5? I'm going with +6 and -1, and the outside and inside check out to give me a +5, yay. And that's the one that gives me the x plus 1 and the x minus 1. And then this part isn't going to factor anymore, and it'll give me imaginaries. Now I can factor it more with the special way I taught you guys. So here's the final answer. This is part of it. Y equals x minus 3. And then this is part of it. X plus 1 and x minus 1. And I hope you know those will give you all real roots. And then the last part, which is x squared plus 6, that's the kind you have to use special ninja factoring for. I personally can do it. Can you? X and x, and plus and minus, and I, because I know it's imaginary answers, and square root of 6 and square root of 6. That means the final answers for the reals are 3 and -1 and +1. And for the imaginaries, it's +I root 2 and I root 2. 6. Wait a minute. That's a root 6. Ah, I wasn't even there. And I caught myself. Yay. All right. So positive and negative I root 6 were my imaginaries for that one. So I'm going to pause here and find the last problem I want to give you for this. Okay, I think the last one you should do for practice is this one. Number lucky 13. Actually, in some cultures it is lucky. Number 13 is your last problem that I'd like you to do. So, again, my best wishes to you as you study for your final, and I encourage you to do not just the ones that I've told you have to do, but if you need to do some extra problems here and there, do it. Check them with the answers on the key. Make sure you look tonight at your list of the tests that you really ought to retake, and then you'll make a little list for yourself of here are the ones that I think I should retake, so that when you come to the final, you aren't going, oh, I don't know if I should sign for this test or that test. You need to make yourself that little list so that you can know which ones you want to sign on and which ones you don't. Again, I would only sign off on things that are a couple grades below your normal average. If it's just a little below your average, I don't think it's worth signing, because finals usually people don't do that awesome on. But if it's a couple grades below, that's the kind of test you ought to be ready to sign for a retake. All right, that's all I have for you, and I wish you the best of luck on your finals. I look forward to seeing your results and when I get back. All right, take care. Bye-bye.